Hello, everyone. Thanks for coming in here and hanging out with me for a little bit today. So as David mentioned, my name is Cody Arkland. I'm with HashiCorp. I am technical marketing, which means that everybody has a natural distrust of me, which is okay. I'll try not to send anyone brochures or postcards or anything like that. What technical marketing means is I like to take the technical stuff that we do at HashiCorp and put it into content that people can consume and see how it works inside of their environment and actually how to solve problems with it. So you can find me on Twitter. I'm super active there. If you ever want to engage, it's probably the best way to get hold of me. I respond far faster to tweets than I do to emails these days. So keep in touch on there. So with the theme of camping, I wanted to start off with kind of a maybe a little of a cheesy reference, but it's summertime in California, and we're going to start talking about what it's like to go to camp. And when I think of going to camp, I think of being a kid and you go to these areas where there's just several camps inside of this geographic kind of area, and they're not necessarily all the same camp. They're part of this bigger kind of community, but they're separate. And when you think about getting stuff between those, you think about the story from all the movies of people like sneaking out of camp and sneaking across like these untrusted roads and these weird backwoods paths to get to the other camp and see your friends, or to drop something off, or to pick something up. And I thought this concept that like the data center is that way, and the way that we're doing Kubernetes right now inside of most environments is very similar to this. We have these clusters that live inside of these different data centers spread out, and we kind of don't trust necessarily the roads that these go across to reach out to each other. And what I want to talk a little bit about in this session is how we can try to fix that with Consul. So what if those roads were trusted? What if we took all of these camps that were different, all these data centers that were different, and we brought them into one major camp, and we knew the roads that went between these, we knew the paths, these were trusted paths that we were on, and we were able to feel safe going across them. Wouldn't that be a world that we all want to live in? And that's what we do in Consul. When we talk about kind of modern application networking and the way that we tie applications between environments, we want to be able to progressively deliver applications. We want these applications to not be just an on-off switch. We want to be able to gradually roll these platforms out and limit our blast radius, make it safe. James Governor talks about, from Red Monk, talks a lot about this idea of progressive delivery. And it's something that we very much believe in inside of the Consul space. How can we make a platform that things roll out smoothly, and we're able to gradually roll out these changes, as opposed to just dropping a service in and saying it's in site 1 or site 2. Also, the idea of zero trust networking. How do we ensure that communication is allowed? How do we restrict communication when we don't want it to happen? And then obviously, like, observability is always a big word, and I don't think I need to unpack that too much, but how do we see what's happening with the traffic? Many people have heard about Consul. Consul has a lot of cool things that it can do. We talk about internally that Consul is a tool that helps people figure out how to solve these complex application networking problems across a number of stacks. It's not just about being cloud native today and fully in the Kubernetes ecosystem already, but how do we gradually move people there, and how do we create this environment that makes it easy for people to move into this more application-centric networking working path. As of last week, we dropped our 1.8 release. So Consul 1.8 is live, and it opened up a ton of things around making service mesh adoptability better. Service mesh gets this kind of weird look in the community because we throw around the phrase a lot, but I like to think that service mesh is more about what you get out of it. It's more about the workflows. And at HashiCorp, we have this TAO that we follow. And one of the points of the TAO is workflows over technologies. We care about, how do we get somebody automatic MTLS? How do we allow somebody to gradually fail applications between data centers? How do we control the flow of that application and say that 75% is going to this service, but 25 goes to this new service that we're bringing up, or even a new version of that service, right? Like, it's not always about replacing app 1 with app Q. Sometimes it's about app 1 version 1 going to app 1 version 2, and then more often it's app 1 going to app 1 version 1 going to version 2. How do we make that gradual and smooth? And a lot of what we did in 1.8 was around that, through our ingress gateways, through our terminating gateways. So ingress allows people to come into the cluster, and this is consistent between both virtual machines and Kubernetes. And that's an important thing to call out, because we want to give people a path to getting to where they need to be. And in order to give that path, you can't just be all in on one way or the other. You have to be able to set up a gradual adoption path. At least that's what we believe. And then terminating gateways allow you to access resources that are outside of a traditional service mesh environment, but still be able to apply those policies to that termination. So terminating gateways sit alongside something like maybe an Amazon RDS instance or a managed Postgres in Azure, and it sits on that edge and allows you to communicate securely, apply those same traffic policies, apply that same the same security from an intention standpoint. It terminates MTLS at that gateway. And what we're talking about in this presentation is specifically this third bullet around how do we make multi-cluster Kubernetes easier to work with, and how do we make it easy to mesh these multiple clusters and even virtual machine environments together. In this presentation, we're focused on the Kubernetes story and how we take a vSphere cluster running Kubernetes and actually have it be completely federated to a Kubernetes cluster living in Microsoft Azure. But sometimes that might be virtual machines living in vSphere, and we want to have that same type of the federation relationship between those VMs and that AKS cluster, and be able to do that same traffic shifting policy to gradually move that application instead of on-off light switching it in. So what we did with the mesh gateways and WAN federation in this release was make it so that we can do this over a single port now. We've had this capability for a long time, but it required communication from each of the server nodes in a Consul environment, being able to talk to the server nodes in the other location. So what this ended up being was multiple ports exposed. And especially in a Kubernetes environment where you're going to likely have overlapping IP addresses, this became very complex to actually have solved in a way that was actually really consumable. So what we've done is we've introduced the ability to truly federate over the WAN, and we use this single port. And in this demo that I'm going to show and get started rolling with in a moment here, you'll see this is running into my lab at home. So I'm an avid home labber. I see a few people in the attendee list who know that about me. And I still have, even though I don't work for VMware anymore, I work for HashiCorp now, I still kept my home lab. I still use my home lab because it's the best way for me to learn. And so within that environment, I'm only exposing that Kubernetes cluster out over NAT over a single port, but I'm still able to federate that to an AKS cluster living in Azure and have it all traffic move through that application traffic, as well as all of the Consul, hey, are you alive kind of gossip traffic. Finally, and this kind of was a more quieter release for us, we actually recently added the Consul Helm chart to the public Helm repositories. So you can actually add the HashiCorp repo to Helm and then install it directly from there. But previously that we had you cloning down the repo and executing a Helm install locally against the clone down bits. And obviously it's not a perfect experience. So we're making that a little bit better. So can I unpack this a little bit already, but we'll go a little bit deeper in it. We connect these environments over a single port, and this could be any type of platform, whether it's Kubernetes, Docker, virtual machine. We can federate these two environments over that single port, and you get all of those workflow benefits that I talked about before. Automatic MTLS between those sites. The mesh gateways don't actually decrypt the traffic. They pass it through. The mesh gateways are just telling Consul, hey, I know how to get to this service that you're calling when you deploy this application. I know how to get to this upstream. Send it through me and I can get it there. That's actually decrypted at the opposite end of the environment. And we can do these same layer 7 traffic policies between environments. And I see this being like the big thing for me. And I think when you talk about service mesh, you get into both networking, security, and application conversations. And I fall very much more into the application camp. I get really excited about what service mesh does from an application lifecycle perspective. And I think that it's one of those ways that we actually can make people able to successfully and safely deliver applications in a way that doesn't end in a 2 a.m. phone call to a bunch of people to fix it. So let's jump in. As I mentioned, we're going to do this live. We're going to go through and set up this federation capability between the AKS cluster as well as my vSphere environment. So here's my handy command line. You can see see the directory here. We're going to look at the Helm config for the DC1, and I'm going to step through briefly what that actually means. We're using specific images. I'm still using the beta 2 bits for Consul. I just haven't updated that yet, so oops. We're turning on TLS by default. So this Helm chart is going to deploy Consul in a secured fashion. So this is like ready for production, good to go Consul. TLS is enabled to secure server communication. It's going to generate a cert within the console for itself. We could swap that out with Vault if we wanted to, but we're not going to in this case. We're turning on ACLs. So ACLs allow us to delegate access and permissions out to aspects of console. So we're turning on ACLs to make it more secure. We're enabling federation. It's going to create a federation secret, which we're going to apply to our second cluster. That gives us all of our communication details. We're going to turn on gossip encryption, which is just going to set up encrypted traffic for all of our gossip communication. Some PVC stuff around setting up our storage. We're turning on the UI. We're turning on Console Connect, which is the service mesh capabilities of console. And then the most important part, well, probably not the most important part, installing it is the most important part. The big call out here is the mesh gateways section, where I'm setting up that my external WAN address, which is for my home lab, and then the port that this is going to go out over, which is 9443 in this case. So we turn on mesh gateway. It's going to deploy a pod that's going to have a mesh gateway with it. It's going to set up a load balancer. You know, shout out to Duffy for all that time ago teaching me about Metal LB for on-prem, because I still use that today. So we're using Metal LB to get my load balancer inside of my vSphere environment. So we're going to go ahead and start this deployment. So we'll just do a pods real quick so we can see there's nothing in here. All I have is Vault running in this one. It doesn't really do anything in this demo. It's just there. Everyone feels more secure with Vault. So we'll finish up that command. We'll send that off, and it's going to start actually running. And while that starts running, I'm actually going to switch into a new tab and start to unpack the other one, just because we're a little short on time, obviously. So in the secondary data center, we look a little bit different. We're bringing in some secrets. So what you'll see in a few moments is I'm going to actually export secret or a federation secret from the primary cluster. And we're going to apply it to this secondary cluster. And that's just going to have all of the gossip encryption stuff. And what this means is, like, you don't have to manually go in and set up all of these certs and all of like the trust chain, as well as like the gossip encryption key and server connectivity details. We give you an easy way to pull that out of cluster 1 and just drop that into cluster 2, so that when you do the install in cluster 2, it just collects that information and sends it off. So let's take a look and see if our deployment's done. Oh, we're waiting for it to finish. Still running. I know what I did wrong. I got ahead of myself. I have to give it the gossip encryption key first before we can get started. So we'll go create secret. Actually, we'll switch back over here. And we'll see if we can catch it now before it actually fails. Should actually pick up and start going now. See, get ahead of myself in the demo and forget steps. Oops. So we're coming online. We could go in and look at the logs on those. It's not going to do much for us. The connect injector is running now, which means that that's how it injects this Envoy sidecars for the service mesh services. Go ahead and make this easier. We'll just let that run. We're going to hope that that doesn't fail, since I took a little while to get started. We can see the mesh gateway starting to come up. Mesh gateway is initializing. And it should be good to go now, even though it's not fully up. And if we do a kubectl get service, I need to do something off screen where I take this and plug it into my NAT real quick, just to make sure that my NAT policies grab it. All right, so we're good there. So now if I do the original path that I talked about, if I do a kubectl get secrets, if I spell it right, we can see that console federation secret there. We're going to dump that out to a file locally. We're going to apply this to our secondary data center. And then we will do our Helm install for our second data center. There we go. And similarly, what we'll do over here is we'll switch this back to, it won't go what, control get pods again. And we can watch it start to come up. It takes a little bit longer on the secondary side because it's going to set up that federation relationship. So we'll do a kube control get service again. We can see the console UI is available here. So I'll go ahead and bring that up. Bring it onto the main screen. Since it's self-signed cert, we get the angry cert rage. See our primary location is up and running. To speed this along, I will go ahead and apply our primary sites connectivity or our application. So we'll go hash demo app, demo DC1. And just so you can see what's actually in that configuration, there's a few items. We're creating a service account. Since ACLs are turned on, it wants a service account to secure communication inside of Kubernetes. We set up a couple of annotations that control how Consul's going to communicate. So in this case, we're setting it as an HTTP service so that we can do layer 7 stuff later if we want. We're not going to do that in this demo, but just so we can do it in general. We're going to set up an upstream pointed at our API in the secondary location on the AKS cluster. And then we create a service for it externally, which is external is inside my house here. So we should be seeing that come up. There's our front end. Let me go ahead and open that on another screen. And we can show that running. So the app's running. We have no connectivity though, because obviously the secondary data center is not up yet. Unhappiness on the bottom right as it doesn't work. So switch back over and take a look at our cluster. Containers are still creating. It takes a little bit, like I said, it takes a little while in the secondary location to come up. Should be able to run up here and very soon though. If we don't run out of time first. So while this is running, I'm going to pop up onto the Slack and see if there was any big questions that came up. Nothing in track 1 so far that I see. I see one in Q&A. So the question in Q&A is, what is VMware Kubernetes? It's probably a better question for someone like Duffy who's out in the audience. VMware has a couple of different Kubernetes paths. In this case, I'm just using the cluster API provider for vSphere. So I know that I know there's a number of paths to do Kubernetes on vSphere today, all of which are quite good. I have nothing bad to say in that space. Obviously, I use it here. But in my case, I'm just using the cluster API project for vSphere. And I'm using that because I wanted things like the storage integration. I wanted to use my vSAN at home. I wanted the integrations that come natively within CapV. So we can see this is just about up. Our mesh gateway is finishing up its process now. We can see it's cleaning up ACLs. Everything's up and running now. If I go back in and bring up our environment, our console environment in the primary location, we can see that little tab on top has changed. And I now have this AKS data center. I'm going to bet that it fails the first time because, no, it didn't, because it was still coming up. It takes a little while for it to stabilize. These environments are now federated together. They're sharing ACL information. They're sharing intentions. Intentions are how we secure communications between data centers. Running a little tight on time, so I'm going to go ahead and just apply the secondary config now. This application in DC2 looks a little bit different. Oop, that was not intended. for a couple of reasons. It's got still upstreams just like before. Also got some Vault stuff in there. So I'm injecting my secrets from Vault. So these are just spinning up a Vault sidecar and injecting the secrets into the application. The Vault, it's a funny story. I actually forgot to install Vault on the secondary location. So while Caitlin was asking me to check in for this session, I was scrambling to install Vault on the fly. So in about 10 minutes, I was able to get Vault up and have the secrets set up for this app. So it's a pretty slick process there. So our app's deployed successfully. If we go and take a look inside of console, we can see it in the secondary location. If we go into the primary site, we take a look at our front end, and we look at our front end service, we can see that it is talking to that AKS cluster. So that is now secured between those data centers. I'm still failing communication, and that's because I have no intentions in place. So I'm going to create an intention that says my front end service can talk to the API service in the secondary location. I'll do allow. Oh, so that is because ACLs are turned on. I need to grab the ACL token real quick so we can do that live just for fun. So there's my Bootstrap token. That's normally you would not use the Bootstrap token for everything, but in this case, we are going to go ahead and use it. We'll paste that in. There we go. Now I have access to create a front end to API intention and allow communication. We should see this pop on in a few moments here. There we go. API connectivity is good. And then if I do the same thing for API going to DB, we should see that pop up green as well. Now, if I go into here, I can send a fun little message. What data base am I on? Kubernetes 1, because we are cloud native now, and we can see that injected successfully. So in about, call it 15 minutes or so, I was able to take two clusters that live in very different environments and connect them over a single port. These services are now communicating over MTLS, so they are secured across the WAN effectively. And I'm not going to be able to do it in this demo, but I'm able to apply policies. So if I wanted to have that API come back on-prem, I could apply a splitting policy that says 50% of that API traffic comes back to the local data center, 50% goes across the WAN. It's kind of a crazy way to split. I don't know if I would recommend that for production, but it's Wednesday, so we can just YOLO that if we want to. We'll take a look at the Q&A and see if there is anything else popping up in this list. Nothing immediately in the list. Anything in the chat? Nothing in the chat. And that is it. That is the demo. So I'm going to switch back over to the presentation and wrap up. You'll see a QR code on the screen. You can hit that QR code and it'll take you to the beta announcement for 1.8. It's actually general availability, so that's a typo on this slide. It was generally available last week. All this stuff is in the, everything on the left-hand side of the screen is all in the open source product, so you can take a look at the WAN Federation stuff I just did here. You can spin this up in your environment right now if you wanted to. So take a look, have fun with it. I'm going to hang around the Slack for a bit and answer any questions that people have. Thanks for giving me the time. This was a blast. Hope everyone has a great day.